Welcome back to my YouTube class again. In this video we are going to explain about equation of motions. Okay, this is chapter 1 motion. Still we are in the chapter 1 motion. So here we have equation of motion. What is equation of motion? If we talk about equation, so there will be some change in velocity or change in acceleration or change in time. So all these velocity, time and acceleration, how they relate each other. So by using equations we are going to show their relationship. Okay, what is graphical? Here we have graphical method to derive the three equations of motion. We have first equation of motion, second equation of motion, and third equation of motion. uh, how will we derive the first equation of motion? Let's see here. uh, let's Here we have considered a body moving with a uniform initial velocity u is the initial velocity of a body in a straight line with uniform acceleration a. That means initially our velocity is u, but we are moving with a constant velocity, now with uniform velocity u in a straight line with uniform acceleration a, and in the time interval t it attains final velocity v covering a distance s. The v-t graph of a uniform acceleration of motion of the body with initial velocity u. Initial velocity u, why it is 0 here? U initially we are at rest. We are at rest, so our velocity at that stage will be 0. Okay, then see here on the right side, figure 1.12, we have velocity time graph. Okay, uh, time graph. This part horizontal line is x-axis, that is time, uh, and the vertical line is y-axis, that is velocity. And then this velocity and time start from origin O. Okay, then initial velocity u is a or oa. This oa is called initial velocity. This oa is called initial velocity. Then since we are moving with a uniform acceleration or uniform uh, speed, then in this case, here we have draw the perpendicular lines BD and BE from point B. That means we have to draw perpendicular lines BD, BD, then BE from point B on time axis. This is time axis, this line is time axis. Then here we have B, and here we have B and BE. Where is E? BE. Here also you have to draw perpendicular line. Okay, then OA is equal to CD, that is initial velocity. OA, this OA is equal to CD, since this is initial velocity. Okay, then final velocity OE is equal to BD. Where is OE? Final velocity. Here we have E and here we have O. That means OE equal to BD. BD. This distance is final velocity. Okay. Then time T is equal to OD. This distance OD is our time corresponding to point B on the graph. Okay. Using this graph, we are going to form equation of motion. First, equation of motion. Okay, let's form in this side. Yeah, also draw AC parallel to OD. AC parallel to OD. Here we have A and C. This AC is parallel to OD. Okay, they will never intersect these two lines. So such that OD is equal to AC, that is T. OD is equal to AD. Their distance, their length is equal in this case. That is time. Then we know that acceleration of the body is equal to slope of the straight line. That is, acceleration is denoted by A. This A is acceleration. It is equal to BC divided by AC. BC divided by AC. Okay, B is this and C is here. That will be BC divided by AC. That means AC is our time and BC is what? Okay, this is the slope of this graph. Okay, so this will be our acceleration. Here we have A equal to BC by AC, and BC is equal to what? BD minus DC. This BC is equal to BD minus CD, and then AC is still AC, here also AC. Again, BD minus CD divided by OD. Why it is OD? Since AC and OD are equal, so we replace AC value by OD here. Okay, then so on substituting the values of BD, CD and OD, we get BD is what? BD minus CD, that is BD is final velocity V, or CD is the initial velocity U, OD is time T. That means A is equal to final velocity minus initial velocity divided by time, or if you rearrange all this acceleration, velocity and time, it will be V is equal to U plus AT. Okay, V is equal to U plus AT is the first equation of motion. Here, this is the first equation of motion. Now, second equation of motion. Distance covered by the body is equal to area under the graph, and time exists. That is, distance covered by the body. Okay, here in this graph, what is the distance covered by a body? Area under the graph. See, here we have trapezium. This and this and this. This is trapezium. And then if we want to find the distance covered by a body, we have to find the area of this trapezium. How will we find area of trapezium? Here we have a formula. Area of trapezium OABD is given. Sum of two parallel sides divided by 2 into height. Sum of parallel side. Where is parallel side? This side and these sides are parallel. Then divided by 2 into height of this. Height is what? This time frame is height. Okay, OD or AC. This is the height of this trapezium. Okay, then see, half into OA plus BD. That means sum of parallel side OA, this is OA plus BD is this side, into OD. OD is what? OD is the height of this trapezium. OD. This is the height. Okay. This and this are parallel side. This is the height. So you have to divide this by 2. Okay. On substituting the values, we get OA. Actually, what is OA? OA is initial velocity u. See, OA is equal to u. Then BD. What is BD? BD is final velocity. BD. That means u to B. That is final velocity. V. Then OD is what? OD is time T. Then half into u plus v plus t, or again on substituting the value of v from the first equation, that is v is equal to u plus at. Then replace, substitute v equal to u plus at, so it will become s is equal to u plus at. This u plus at, instead of v, we have to use u plus at, then divided by 2, so into time. Okay. Then remove bracket. If we remove the bracket, we have to add u and u, so it will be 2u plus at is at divided by 2 into time t. Again, on rearranging this, or here at the denominator, see, s is equal to 2ut plus at square. That means we have to we multiply with this t and then divided by 2. Okay, t in can multiply that. On multiplying with t, we will get 2ut plus at square divided by 2, or then you have to split this. Okay, so 2 ka LCM ka nita, LCM kan split ta, we get 2ut divided by 2 plus at square divided by 2. Then 2ut divided by 2, eliminate 2 and 2, then we'll get ut only, then plus at square divided by 2. This is the second equation of motion. Okay, second equation of motion. Then where's the okay, we still left out third equation of motion. Okay, see here we have uniform acceleration. Okay, next class we will discuss about the third equation of motion. In the next slide, we have uniform circular motion. What is uniform circular motion? The motion of a body around a fixed point in a circular path is known as circular motion. Circular motion in this case, see, a motion should be in a circle shape. Okay, initially your body start moving from here, then it will move like this. Okay, this is called circular motion. Object moving in a circular path is an example of accelerated motion, because acceleration is change in velocity. If we change our direction, that means we are changing our velocity too. So this change in velocity can be due to change in its magnitude or directions of motion, or both. This is called acceleration. Okay, motion around a circle or a circular motion. This is example of acceleration. Okay, why it is a good example of acceleration? Because if we change our direction, it implies that we are changing our velocity. Okay, when an object moves in a circular path with uniform speed, it means that its magnitude of velocity does not change, only its direction changes continuously. Hence, it is considered as uniformly accelerated motion. Velocity is given by distance divided by time. In this case, since our motion is in circular path, so it is circumference of a circle. We can say circumference of a circle. Then circumference of a circle is given by 2 pi r. Then velocity will be 2 pi r, since you have to divide the distance by time. So 2 pi r divided by time is called velocity of that circular motion, where t is the time taken to complete one round and r is the radius of the path covered. Okay, here t is the time taken to complete. Initially we start moving from here, so our time taken will be to reach this. Okay, again, then when an athlete throws a hammer or discus in a spot, meet his rotating body gives the hammer or discus a circular motion. On releasing in desired direction, the hammer or discus move in the direction in which it was moving at the time it was released. Then okay, this is examples of the circular motion. Okay, this is example of circular motion. Now in the next slides we have differences between uniform linear motion and uniform circular motion. What is uniform linear motion? In this case, a body moves along a straight line, but in circular motion it moves along a circular path. Then the direction does not change in linear motion, but in circular motion the direction changes continuously. Okay, then linear motion, both speed and direction remains constant, since it is straight line movement. But in uniform circular motion, speed remain constant, but your direction will change, okay, continuously. It is not accelerated motion. Linear motion is not accelerated motion, but circular motion is an accelerated motion. Okay. Now your homework will be in homework on Suyang. In homework at John, you have to write down all these first equation of motion, second equation of motion, including this diagram and this statement. Okay, here you have to write all these statement and the diagram also, and all this first equation of motion and second equation of motion also. Then from here you have to write uniform circular motion statement, uniform circular motion from here to from there. Okay, then in this case of circular path, okay, you have to write this also up to this. Okay, up to this. Hipohi ziatur. Again, this also you have to write down. Hipohi in ziakang. Engenge ta in homework chole. Hi in ziakang nga. Chuan uniform circular motion hi. Hi hetilai tang hian. Titleng in ziakang nga chumizo. Hetilai atang hianin. Hetilai cover. Titleng in ziak bong. In case of circular path, distance move in one rotation, that is perimeter, is equal to circumference of a circular path, that is 2 pi r, or we can say velocity is 2 pi r divided by time, where t is the time taken to complete one round and r is the radius of the path covered. Up to this much you have to write. Then here all these, including this figure 1.12 and then this. Okay, you have to copy it down to your notebook and submit it to me before 7 p.m. Thank you.